Hello everyone, today we are solving another lead code problem, that is n queens. This is very standard backtracking problem. So let's see what is the uh, problem statement is and how we can approach this problem. So the question says that you are given an integer n. Let's say you are given integer 4. So you have to place 4 queens, exactly 4 queens, n queens, like an integer n will be given. So you have to place n queens on a n by n chessboard so that no queen is under attack. I'll take an example. Let's say n is equals to 4. You have a 4 by 4 chessboard, which will look like this. So this is 4 by 4 chessboard. Now we have to place 4 queens on 4 different rows, like one queen on this, one queen on this row, one queen on this, one queen on this, one queen on this, so that all the queens are not under attack. Let's say we are putting queen 1 here. So next, can we put here? No. Can we put here? Can we put here? Yes, we can put here. Can we put here? Can we put here? Can we put here? Can we put here? No, we cannot put. We are out of options. So what we have to do? We cannot put this queen on this. Let's put this queen on this. So can we put here? No. Can we put here? Yes, we can put. And similarly, can we put here? No. 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 Okay. So we are out of options. So we cannot put this queen here. So can we put this queen here? No. Can we put here? No. So we are again out of options. So we have to go there. So can we put here? No, we were out of options. If we'll put here, then here also we tried. So now we are out of options for this row as well. So we'll go here. Let's put this queen here. Can we put queen 1 here? Oh, sorry, queen 2 here? No. Here no. Here no. Here no. So we can put it here, queen 2. But let's put queen 3. We can put queen 3 here. And again, for queen 4, we can put it here. So yes, this is one solution for the 4 by 4 uh, n queens problem. Okay, 4 by 4. For n equals to 4, we get this solution. Okay. Now multiple solution can be possible. If we let's see another solution. If we put queen 1 here, then queen 2 here, then here not possible, here not possible, not possible, queen 3 here and queen 4 here. So this is another solution. So we got 2 solutions. So we have to give all the possible solutions for this n cross n chessboard, placing n queens. Okay, so this is the problem statement. And how we have to return it? Let's say, like for this solution, we have to return it first vector, array of vectors, a vector of vectors, and the vector will contain dot q dot, because these will denoted as dot, and the where queen is played, it will be denoted as q. Okay, again q dot again dot q dot q, and again dot q dot. So this will be the solution, and the previous solution will be also there. So we will be the vector will be containing 2 vectors, which one is this and one with the other solution. So how we can approach it? So this is a classic backtracking problem, because we are while solving it manually also, we were backtracking it. Okay, we ran out of options, so let's backtrack. We run out of options, so let's backtrack. So we are backtracking. So the problem will be consisting of, I guess, 2 main subparts. First is like, how do we know that the queen is under attack? First question is this: how we know that queen is under attack? So this is the first part. And second, then backtrack. If you know that queen is under attack, then backtrack and try different option. So let's check the how we can get the queen is under attack or not. So for a chessboard, when queen will be under attack, I'm taking a small chessboard for explanation. So when the queen will be under attack, let's say this is a queen, so we cannot put it here, queen to here. Why? Because let me denote it as row number and column number also, because the column number is same. So if column number of the queens are same, that means the queens are under attack, so we cannot put it here. Okay, can we put it here? No. Why? Because diagonal, so we cannot put on diagonal also. So mathematically, how we denote diagonals? Okay, let's see. So 0 comma 0, if one queen on 0 comma 0, we cannot put the other queens on 1 comma 1, 2 comma 2 and 3 comma 3. Can you find a pattern in this? Similarly, this diagonal also, if a queen is on 3 comma 3, sorry, 0 comma 3, we cannot put it on, we cannot put 1 comma 2, we cannot put on 2 comma 1, we cannot put on 3 comma 0. So what pattern we are finding? The pattern which I am thinking is, see, for 2 comma 2 and 0 comma 0, 2 minus 0 is equals to 2 minus 0. Are you getting? What I am saying is that row number, the difference between the row number and difference between the column number are same. Similarly, let's take this 0 comma 3 is equals to 3 comma 0. If I take absolute value, 0, so row, so I got the mathematical expression that absolute of row 1 minus row 2 is if it is equal to absolute of column 1 minus column 2, then that means these two queens on row 1 comma column 1 is in attack with column row 2 comma column 2. So row 2 comma column 2 is not feasible, you know. I guess you got the idea. So let's check for the pseudocode, what how it will look like, the pseudocode. Okay, so first we'll make a function is possible. Is possible is a function, like if it is possible, what it will return true or false if the queen is possible at that position or not. Putting the queen at that position is possible or not. And how we'll know? Okay, before discussing this, let's discuss how we will store the previous, because for putting queen 3, we should know the position of this queen and this queen. Then only we can predict the position of the third queen or fourth queen. Okay, so how will we gonna store? We can make two arrays or a 2D grid also, 2D matrix to store the position. But what I am thinking that we have to place one queen in one row only. We like queen 2 will always come in the second row, or if index wise we'll go in at the first index, and queen 3 will always come in the third row or the second index. So we can take a simple array. Index will denote its row number, like 0th row, and at that position, like if we put the queen and at the second position, so 2, so this 2 will, what 2 will denote, that the queen at the 0th row is at the second column, the queen at the first row is at the third column, or any column which we put. So we can store it in simple array also. If multiple queen were there, we have to put multiple, like that is not possible. Multiple queen in one row is not possible, it will be under attack. But if the such case will come with some different with some different pieces of chess, we can use the 2D grid to store. That will give exact location of the queen or the piece. But for queen, since we can put only one queen in one row, we can use a simple array. Now let's talk about the is possible function. What it will take? It will take the row number, column number of the position, like position at which position you are trying to put, row number, column number, and the previous queen's data, that where the rest of the queens are placed. So that array it will take, okay, the previous queens. Okay, So it will iterate like let's say we are putting the fourth queen, and we know that 1 2 3, these are random numbers. We have to put the fourth queen. So let's iterate over this array where the first queen is, where the second queen is, where the third queen is, and check if the fourth queen will be under attack at this position by putting the fourth queen at this position. Okay, so for I less than uh, row and I plus plus. Okay, we have to go this till this row number, like fourth row or fifth row, that is uh, now if the array of I, like array of 0 is equals to row number or column number, row number. Okay, because this index, what index is denoting, index is denoting the row number, and the position is denoting the column number. So this is column number, so we cannot put row, column. Okay, or this 0 is put denoting the row number. Okay, and one is denoting the column number. So if array of I is equals to column, or what I said, the diagonal condition. Diagonal condition was, what was the diagonal condition? If the diagonal condition, where we have written the diagonal condition, yeah, absolute of this. So absolute of this. So absolute of row 1. What is row 1? Index is denoting the row number. Row I minus answer of I. Row 1 minus row 2. Answer of I is the okay, is equals to absolute of column 1 minus column 2. So what is the column? Oh, sorry. I minus the row where we are putting the, so this is what, row 1, this is row 2. See, row 2 where we are putting absolute of column, that means array of I minus column. If it is, if these two condition, any of these conditions are true, return false. That queen is it means that queen cannot be placed at row comma column. Okay, else return true. After this loop, return true. Have you got it? Okay, now the main backtracking part. Now the backtracking part is very simple, very straightforward. We'll take what, we'll take first a integer k or index you can take, mostly we take index. Okay, why what it will denote, like which queen, first queen, second queen, third queen, it will denote the position of the queen. Okay, now again the array in which we'll store the positions of the queen, and a result where we will store the result. So this much only we need to what do you say, we need to get, and let's see if we need some more data structures, we'll figure it out later. Okay, so if index is equals to, and it means if it is the last queen, then we have to store the result, and result will be in this array. Okay, else what you have to do, for int I equals to 0, like we have to check all the columns, we have to check all the column, this, all the columns. So options are this option, this option, this option. So options are always in backtracking, options are through loop I less than and I plus plus. So if is possible, call is possible function, if is possible at this row with this column, and again array we have to pass. If it is possible, then what you have to do, answer that push, answer the dot push back this column, answer dot push back, and again solve for the next queen k plus 1 and rest parameters. Okay, and answer dot pop for backtracking part, answer dot pop back. Okay, so this is the pseudo code, or you can say the exact code we have written. But yeah, one more part, what this will give, like it will give you an array, result array will look like like 1 2 3 4 0 1 2 3. This is like the result array, but we have to give, like, if the uh, answer is 1 2 3 4, we have to give q dot comma q. So in this form we have to give answer, so we have to convert this answer into the uh, this technique. How we can do this? Okay, I just find out that we have to return uh, in this form only, but the only thing is that we are pushing I plus 1. Okay, so it will come like 0 if it is placing a here. So the in our array it will be column number 0, but we have to return as column number 1. So we can do I plus 1 here. Okay, push back I plus 1, but again here it will cause any issue or not. Let's see. If it is 1, so ARR of I is equals to column. Here also we have to make I plus 1. Okay, or start I from 1, we can start. Okay, so let's try to solve and code if it is. Okay, let's expand and yeah. So for the basic part, what we will require an array which will consist your answers, and we'll require a result array which will contain all the array of answers. Okay, result, and now we can write the solve function. Solve function will take k, as you said, to will start from the 0th row I am putting as 0, and column will start from 1 onwards. Okay, because answer is expected from 1 onwards. Okay, now answer, result, and also we have to pass so that it know where we have to start. Okay, and then return result. Okay, let's write this solve. Solve will not return anything. Void solve. It will take int n k vector int error array. Here it should be array. Okay, now this part I should copy. And comma int n. Okay, now if this k reaches index, like last queen is there, then just result dot push back an array and return. Okay, if it is not there, we have to try all the possibilities. I equals 0, like column, if we are starting from 1, so let's say 1, I less than equals to n, and I plus plus. Okay, so if is possible will take your row number, and here row number will be k, column number will be I, and array we have to pass. Okay, if it is possible, then answer, array dot push back array dot push back I, and solve for the next queen, which is k plus 1, array result and n. Okay, and array dot pop back. Okay, array dot pop back. Yeah, this much should be. And let's write the is possible. function, so it will return true or false. So it is a bool type. Is possible. If it is possible, it will take an int row, int column, and what it will take vector int array. Okay, so if we have to check it for the all the queens now. So for int I equals 0, I less than you can say row I plus plus, because we have to arr.size will also work, or you can go to row also. Okay, now if answer of I plus 1, okay, no, sorry, I that is because column number is the same. Okay, so if answer of I is equals to column, or what was the condition, row sorry, row 1 minus row 2 is equals to column minus column 2, or this condition. Okay, row 1, what is row? So row is this I is row. Okay, and answer of I is column number. So if row 1 minus row 2 is equals to column 1 minus column 2, but this should be absolute. Absolute. Okay, if this is the case, then the queen can be placed there, so return false, else return true. Okay, so yeah, let's see if it is giving me the correct answer or not. Okay, where is it? Compilation error. And now, okay, here also it will not int. Okay, let's try now. Okay, we haven't passed it by reference, we have to pass it by reference. Okay, now let's see. Yes, it is giving us the correct answer. Let's submit and check if it is working for all the test cases. Okay, let's submit again. Yes, we have done it correctly. I hope you understood this problem. This problem is very classic and standard. Thank you.